One of the common usages of using animatables is aligning with gestures and synchronizing your animations with gestures. In this video, I'm going to show you how to use animatables aligned with gestures, and I will show you two use cases for such scenarios. So I already have this, I have designed a layout that has two parts, an upper part and a lower part. And for the upper part, I have an image that is supposed to be moved around based on the tap on the screen. And for the second one, in the second layout, I have an item that is supposed to be dismissed out of the UI tree based on the user's fling to the sides. So I will show you how to implement these two items using animatables. So for the first one, as you can see, I have an animatable called offset that defines the location, the current location of my B on the screen. Of course, the upper part only, because I have used the B image inside the box. So I'm gonna use, as you can see, the offset on the image as a modifier, and it is taking the up-to-date value of offset. And the next step that I need to do is applying the pointer input modifier on the box. So I use pointer input with unit as its key, and in its pointer input scope, I'm gonna run a while loop inside the coroutine scope. This is gonna be an infinite loop while true. And here I wait for the tap gesture. So await pointer event scope. I call this function inside coroutine scope so that I can detect the tap gesture. And here I wait for first tap. Await first down. To optimize CPU usage, I'm gonna close the preview pane for now. This is gonna return a pointer input change from which I need only position. So val pos position, and then I launch a coroutine to move the animatable to its new location. So offset animate to the new location. Note that the offset is not known here because I have defined it later. Let's move the definition before the usage inside the modifier. So I move it upper in the tree before the definition of the box. Alright, offset animate to position, and because I'm gonna show that with an animation and exaggerate it a little bit, I'm gonna use a custom animation, a spring animation. Let's import spring, and then for its damping ratio, I'm gonna use a damping ratio of high bouncy. Alright, let's run the application and see the results so far. Alright, I click on the box. There we go. You can see that RB is animated and it moves to the new offset and to the new location based on where I click inside the box. So you can see that I simply added an animation using animatables and tap gesture. So you can see that I simply added an animation using animatable and tap gesture. Next, I'm gonna move to the second box and implement the swipe to dismiss animation. For that, actually I'm gonna define a modifier, a custom modifier. So that custom modifier needs to be defined as an extension function of modifier, and then I can use that modifier of mine on any item that I want to be dismissible with swipe. So swipe to dismiss, I call it, and I define an action to perform when the swipe has happened. So on dismissed, it's gonna be a lambda that doesn't return anything, and this modifier will need to return a modifier so that it can be used aligned with other modifiers in a chain of modifiers. Composed, it equals composed. Composed is a function that allows you to define your custom modifiers, and make sure you return a modifier inside the composed block. So here I define an offset that is very important for me, val offset x, because I'm gonna move the item in the x direction. So remember animatable 0f, this determines the x offset of my item on the screen, and then I'm gonna run a pointer input to detect the gestures. I'm gonna pass in unit for it, and after the pointer input has been called and it has detected the gesture, it's gonna need to return to call offset, because the new offset will use the final value of offset x that I will be modifying inside pointer input. So int offset needs to be returned, and for its x component and parameter, I'm gonna use offset x dot value. Because it's integer, I cast it to integer. Round to int or to int can be used for that. And I don't touch the y component because I don't want to move the item vertically. So let's now detect the swipe gesture. Before that, I'm gonna use actually swipe to dismiss on the item that is supposed to be dismissible. It's the text item that I have inside the second box. So I add, as you can see, the to-do tells you where to use it. So I add swipe to dismiss, and the action that is supposed to be performed is specified with this lambda. It can just be setting a state variable like dismissed. I define a state variable inside the box var dismissed by, remember, mutable state of false. Let's import get value and set value for our delegate to work. There we go. And when the dismiss happens, I'm gonna set its value to true. And after that, dismissed. When that happens, I'm gonna show a toast in my UI tree, and as the final item of my box. So toast.makeText local context dot current is used to get access to the current context of my application. Import toast and show a simple message like dismissed, and its duration toast.length.short and length short and show. And in addition to showing the toast, we are also going to remove the item from our UI tree. So I add an if statement before the text item and say if not dismissed. If the item is not dismissed, then this text element will be shown. Otherwise, you need to remove it from the UI tree. It is simply a matter of adding this if statement. It's very simple. You just decide to either show it or not show it. And now the hardest part and the challenging part that I hope will go smoothly and without problems. And here I run a coroutine scope in which I run a while loop to detect the gestures. And first, make sure that inside your pointer input you need to define a deceleration, a decay, that will be used to add physical properties to our fling animation and fling gesture. For that, there's a function spline based decay. It's a mathematical thing used in computer graphics to implement a type of deceleration for movements and flings. So spline based decay, its type will be float because we will be modifying and working with float value. And as the density that it expects, I'm passing the pointer input this, and I also need to define a velocity tracker. So a velocity tracker that I will use to define and to calculate the velocities. So velocity tracker, I define it inside my coroutine scope. Well, velocity tracker, velocity tracker. I import it from the compose packages, and first I get access to the pointer input, the item and the type of the pointer, whether it's finger or mouse, that points and that taps the screen, taps the item. So val pointer ID, I call await pointer event scope, inside which I can detect first down or first tap. First down, it detects a tap gesture, and then it returns the ID of the pointer. And here I stop the animation, because when I move the item around, I need to stop the current animation that is running, because I need to snap the offset to the new location that I'm dragging the item to. So I stop with launch. I launch a coroutine and I say offset X, stop any ongoing animation, and then I run another await pointer event scope so that I can detect a drag inside it. I can run a horizontal drag with the pointer that I have detected earlier, pointer ID, and then I decide what to do on every drag. On every drag, I'm actually moving the item to a new location, so I need to update the offset to those new values, to that new location. So I call launch offset x dot snap to the new location. How do I know where the new location is? The new location is calculated by calling offset x dot value. It's using too much CPU. I close it, the preview pane. Offset x dot value plus change in position. So change, here I have a change which has a type of pointer input change, and I know that one of its functions is position change. It returns the change delta for me, and I need the x parameter of it, which is float. And also make sure that you add the changes here to your velocity tracker so that it can later calculate the velocity. Velocity tracker dot add position, the time of the position, the timestamp of the position is change dot uptime millis, and its position is change dot position. Alright, after detecting the first tap and then running a horizontal drag, I have obtained the velocity tracker, I have obtained the needed points, and I have moved the item around as needed by snapping it to the new location. But then I need to calculate the velocity. So val velocity equals velocity tracker dot calculate velocity, and because I'm only interested in the x component and in the x direction, I get its x component. And now let's actually calculate the target value based on the fling and based on the force that the user has applied, and based on the velocity that we have obtained, we can now calculate where the final point after releasing it and where the item will stop after releasing it. So val target offset x to hold the target value, decay, I use decay to calculate it, calculate target value. It has a parameter of initial value. Initial value is offset x dot value, and it also has the initial velocity for which I pass in velocity. And now I do a simple comparison. I say let's run a coroutine, and here I say if the target offset x dot absolute value, if this absolute value is bigger than 75% of my width, then I allow it to be dismissed. So I say when that happens, I animate it with decay to the location that it can go to the new offset. So I say offset x dot animate decay with the initial velocity and with the decay animation spec for which I pass in my decay. And also let's not forget to call Also, don't forget to call onDismissed, which is the behavior that we expect to be performed after the dismiss has happened, like setting the state changes, applying the state changes, and doing some other stuff that you might want to do. So otherwise, if the target value is not big enough, if our force was not strong enough, if the final value was not big enough, then we will snap it back to its initial offset. Offset x dot animate to its initial value, and because we want it to look physical and natural, I run a spring animation as its animation spec, and for its damping ratio I pass in a spring dot damping ratio medium bouncy. Alright, let's see what we have. If the target value that we are calculating with decay is as big as the width, in fact 75% of the width, then we allow it to be dismissed and to move outside of the screen. Otherwise, we are animating it to its initial place, which was 0f. Also, because we don't want to run the animation more than it is necessary, we only want to move it outside of the visible area. We don't want to use too much CPU. So we update the bounds of our offset x. It has a lower bound and an upper bound. For the lower bound, I only want this to move as much as the width, as big as the width from the left, and to as much as its width from the right. So I say lower bound is size minus size dot width dot to float, because I want the float. This expects float values. And then for the upper bound, the right side, it's equal to size dot width dot to float. Alright, this means that our offset x can move only as much as the width of the item to the right and to the left, and that's enough for the dismiss to look okay. You can also add a little bit to this if you are worried that it might be a little bit visible after dismissing. So now I think everything is okay. We are detecting the pointer input, pointer ID, then we stop the ongoing animation, we snap it to the new location with a horizontal drag, and then with those drags we calculate the velocity using the velocity tracker, and then we calculate the target offset x, the target value of our offset. If it is big enough to be considered dismissed, then we dismiss it. We allow the item to move to that new location with the decay that we have defined, and then we perform any action that the user wants us to do as the modifier. Otherwise, we are snapping it back to its initial place with a spring animation. And we have used this swipe to dismiss on our text item, as you can see, and when the dismiss has happened, it changes dismissed to true, and then with that being true, we will see a toast. If dismissed, we will see a toast, and at the same time the text will be removed from our UI tree. Let's run it on the emulator and see the result. Alright, let's dismiss it by swiping to the right. First I apply a small force. You see that it is snapping back to its initial place. Now I apply a bigger force, a bigger fling. There we go, it was dismissed. Again, this time to the left, it is dismissed. Nice, not bad. But as you can see, the removal of the item is a little bit sharp from the UI tree. When we are removing the item after dismissal, it's a little bit sharp. As an assignment, I want you guys or girls, I want you as an assignment to add some animation to the removal of the item from the UI tree based on the animation lessons that we have so far in the course. So I hope that you liked this video, and see you in the next one.